Richard, give us the 60-second case for small language models. You talk a lot about
Okay.
them, but specifically, when are convergence dynamics and effective rank the true bottleneck versus just not enough data or not enough steps?
Okay. This is like a layup. You should just check out my paper. Small language models leave a lot of potential on the table. If you take a small model and you take a big model, and we look into the internals of these models, and we see how much of their capacity are they using. Like if a language model is a car, on how many cylinders are these different cars firing on? What you would expect is that a small model, when it's trained on a bunch of data, is basically like firing on all cylinders. It's burning a ton of gas. It's trying to get really good, but at some point, its engine just isn't big enough, right? Whereas a big model has this like massive engine, this like V12, and it can just keep powering through and crunch more data. We found that actually a small model, even though it has a smaller engine, isn't even using like all of its pistons. It's actually leaving some potential on the table, which doesn't make any sense because a large model, surprisingly, is actually more effectively using all of its pistons and it has more of those to begin with. So that then leads us to hypothesize that there's actually some advancements or innovations that we could make to force a small model to actually fire more of its pistons more effectively. It's actually at the level of how you train these things that small models aren't as effective as large models. It's not the fact that they're just small. It's like
Yeah.
something that has to do with their small size leads them to learn worse.
I really like this metaphor that you use about being in this like Martian or moonscape where you're trying to walk
Okay.
around and that's your optimizer, right? And you're trying to avoid falling down these crevasses, but you don't really know where they are. Your supposition that what is being limited is the fact that in this like optimizer landscape, smaller models make it more likely that you will fall down one of these crevasses and therefore leave optimization and capability of the model on the table.
So you remember from like high school physics, right? If you're trying to solve a system of equations and you have a bunch of parameters, but not that many equations, it's like impossible to solve that problem, right? Fundamentally. But then if you add a bunch more equations, and when you have number of equations equals number of free variables, then you can find a solution to that. That's basically what's going on here. This is like almost exactly what's happening in
Yeah.
a language model. You're solving systems of equations. And so as you add more equations, you make the problem you're solving easier on yourself. Did I answer your question?
Yeah.